The random variable z has a standard normal probability distribution. Find the probability that z is between 0.88 and 1.09. Okay, so we know it's a standard normal probability distribution, so we can draw a bell curve then as a visual aid. And then I'm going to label the center of that curve at 0 on my z number line, right? Because the mean is located at 0. And 0.88 would be to the right of that. And so would 1.09. This is important that we're shading between 2 points that are on the same side of the mean, right? They're on the same side of the curve. This is a special case, a special problem that people often find difficult. For example, what happens if I look up 1.09 on my z-chart? Well, I'll get the area from here all the way to the center, which gives me all of the area I want, right? But then it goes past that and gives me area I don't want. So it has too much area. The answer will be too large. If I look up 0.88, remember I always get the area from that line to the center, and that's none of what I want. I don't want any of that area. But that's also the precise amount of area that I'm not interested in the other area that I got. So if I just take away or subtract these two values, if I take the larger one and subtract the smaller one from it, I should be left with the area I'm actually looking for, this area here, right? Okay, so let's do it. Let's go look up 1.09. So here's 1.0 and go all the way out to the end, 1.09, you get 0.3621. 0.3621. So remember, that's this number, 0.3621. Notice how I've written it across the space, right? Including it into the white space to make sure that I'm clear that it's not exactly what I'm looking for. It's more than what I'm looking for. It spills outside of the shaded region. All right, let's try to find the answer when we look up 0.88. So here's 0.8, and then to get to 0.88, we have to go all the way almost to the end. This value here, so we get 0.3106. 0.3106. So that's here though, 0.3106. So we have these two areas and we have to then subtract to find the area we're actually looking for. So we'll take the larger one of the two and subtract, right? All right, so I have to do a little borrowing here to do the subtraction. So we'll borrow here from here to make that 11. 6 take away 11 is 5, and 1 take away 0 is 1, 6 take away 1 is 5, and then 0. So we get the answer 5.15%. If you write it as a percent, it'll be 5.15%, or in other words, 0.0515. So try to remember this little idea. If you can't see what we did from the drawing, if you don't know why we had to subtract here, try to remember that if you're trying to find an area between 2 points on the same side of the curve, you can remember same side subtract, right? So in other words, because you're looking for an area between 2 points on the same side of the curve, whenever they're both on the same side, you must subtract the two table values. So same side subtract triple S's. All right.